I'm making this video because the equipment's available and I want to capture this disassembly process, okay? So if you have this next gen tender with the bells and whistles that we have so far, and you want to take the motor off or take the engine out of the shell, this is how you're going to have to do that. You prepare by removing the linkage from the drive wheels. Then you'll take the rear truck off. It's all normal stuff that you would do. One additional thing is we have these clamps that hold the connectors in for the tethers. So those will have to come off, okay? And they take two Allen head screws. I have one on tight because I was going to do this. I didn't want to waste my time. And I still can't do it quickly. Okay, there we go. Those are out of the way. The cables come out. And there's 4 screws that hold the pan down. We're going to take those out. That one didn't get tightened. There's 1, 2, 3, and 4. Now, these 2 in the back, these 2 go into the field, DC fields that we provide. These 2 go into the columns of the cab that are molded into the bodies of the American Flyer engines. And there's some rework that you're going to have to do to your engines to make that work for you. And I'll get to that. And then the firebox, may have to loosen the front end to get the firebox out. Front end screws are the typical front end screws you always have. You loosen those. Then you have to come off the tab that it slides onto, which I really have trouble with my tabs. I don't like tabs very much. One of my engines is not going to have them. So he slides forward, then you can lift the rear end up like this. Then you can take your firebox out. May have to unplug this if it's fastened or not. We haven't finalized that design. And now you pull the engine back and out and it comes out. There you go. There's the screw I dropped. Okay, so that's how the engine would come out. And the wiring, as you can see, is pretty streamlined, all tidied up except for this back piece. And here's the 2 harness connections that would come out and go to the tender harness. Now, the 2 screws that I mentioned that are important for fastening the ash pan down. The ash pan is going to be bolted to the engine's fields right there, okay? So it's going to have a rigid mount to the engine, but we also want to have a rigid mount to the body. And here we just use these tabs. So we don't really mount to them, but they're kind of locked in. But what I wanted to do was introduce locking it in at the cab, because we used to have that capability. Now what you'll see is I've removed the drawbar from this royal blue. This is a very nasty old royal blue someone loaned me. I don't know who loaned this to me. I'll have to get to them. Thank them graciously. But this is the drawbar that would come on this, and this is riveted in, right? Mashed over. So you'll have to file down these rivets and pull this drawbar out, okay? And when that drawbar comes out, you'll have these 2 little pedestal-like things. And they won't have holes in them. They will have the remains of this stud that this piece drawbar was sitting on. So now, when you have these 2 stanchions with the stud on it, you'll have to file them down to flat. Don't go crazy, just take them down till they're flat, both sides. Then you're going to get a tiny drill. That's how I do it. You get one of my small drills, not a big one, and I hold it just as close as I can to what I think is the center of that pillar, and I just lightly start. This is very thin metal. It will cut easy. And you just start a hole going down. You go down about, I don't know, 2, maybe 3 millimeters, and you have a tiny hole. Then you're going to use, I use 440s to tap that, but the 440 needs a hole to get started. It can't be tapped in that small a hole. Now this 440 looks like it's going to need about a 2.0. So you get a 2 millimeter drill. I don't think I have one around, but not handy. This is a 1.5. So you get it, maybe you go 1.5, then you go to 2, but you end up hand drilling. I hand drill because the electrics in this kind of material and in this delicate close surface can run off on you. Hand drill it, go down to 3 millimeters, then you get your tap out, and you just slowly, you know how to do tap. You start it, you back away, you do it a little further, you back it away. You want to cut the threads, you go it, take it out, clean it off, tap a little more, and get it down to the bottom of the hole. Don't strip your threads. That would be a disaster. There's ways around it, but we don't want to have to do that. Then you get one of your screws that you're going to use. You test fit the screw threads, make sure the threads are good, and that's the one tricky part, to modify this to accept this. Now, if you haven't been watching, you may not understand what you're looking at here, but this chassis did not have a smoke. So I had to cut out a slot. This is one that I have done. I've cut the slot out for that gear to sit, but now there's no post for the gear to sit on. So I've made something. I made a gear holder. Whatever, right? And it will hold the gear in place, and I use my fields again to mount the gear holder piece on, and it mounts on and it goes just like that. Okay, and there's the gear now driven by the motor. So we now have a timed gear with the motor, and we put little sensors on it, different kinds. That's a limit switch. We also have a reed switch, and we're working on some other stuff. And it then creates a pulse of rotation, so we now know when we're rotating. And we take that rotation signal. This is one of the sensors, and there's another one. One of them goes to this PC board on here, and the other one goes back to the tender, to the soundboard. And when it closes, you hear the chuff sound. So you get a chuff sound. Chuff, chuff, chuff. Time to the wheel. Then this is the puff and brake board. And what it provides us is a pulse of energy to the motor that fans the smoke out. So it'll go chuff, and a puff will come out same time, puff and chuff. Now when we are idle and we stop, this is what I call a motor on detector, and this tells me if the motor is off, but I have track power, such as sitting at the station. If I'm sitting at the station, I would like to keep the smoke going, but I'm going to change. It can't be pulsing because we're not driving any pistons, but it would have a slight, small, low speed drizzle of smoke coming out. So that's what we do. We slow it down and we give it a drizzle. One, that keeps the smoke working, so when you take off, you got smoke right away. But it also keeps these components cool as they're working through low levels of energy, but they're still intact. And then when you energize the motor, this senses that and switches the relay to say, okay, go from idle to brake, pulse and brake. And it'll go puff, brake, puff, brake, puff, brake, based on this position. So this is all this is. Puff and chuff smoke, and in a chassis that never had it, and that was a challenge. And the DC fields and fan-driven smoke, timed to the gear, and the paraphernalia to do that. Now for the headlight, I just put in an LED, and I tap it in off of the motor, so when there's track power, the headlight comes on, basically. Not tied into the motor, but or is it? Motor on. Yes. When the motor is energized, that light comes on. Whether you're going forward or backward. Right. Anyway, that's what's going on in that engine. And that engine gets stuffed into this thing. All this stuff, believe it or not, just slides right in. Just like that. And then it goes back together. One, you have to lift this up just a tad to get your firebox engaged. There we go. Now I'm cooking. Got ahead of myself there. I didn't realize what I was going to do. Well, I didn't know I was going to do it, but I'm doing it now, so there. All right. It'll go. Got ahead of myself. Or did I? No, I didn't. There we go. There we are. All right, so that's in place. All right, then we go back to what we call the ash pan. I'm supposed to have an ash pan, but I couldn't. I found out if I close this off, the motor gets hot. Really? Well, yeah, it's electricity and it's making energy, and that creates some heat. You all know that. You had physics in the 6th grade. This bolts down, clamps come in, ties to the tender, boom. Put these screws in, put your linkage on. It's done. Back together. And that's what the ash pan looks like underneath. It's open so you can cool the motor. And that. So anyway, this is what's going on with this engine, and this is what I'm doing. And it's 4:30, so I have an hour to go yet before I get called up. I get called up at 5:30. And I was going to continue to chug away. I'm going to shut this video off. I may or may not post it. I don't know who needs to see it right now. The hardest thing you're going to ever do with this kit so far is, if you have a metal engine, is the screw. Later, I may get rid of these guys and do the same thing and drill and tap. So I'd have a tapped hole here, a tapped hole here, and a tapped hole here. That's the case, then this engine would simply rotate and go, just slide in, screw down the screws, and you're done. None of this push it back, lift it up, get the tabs in, blah, blah, blah. No, that's gone. I'm going to try to get to that, not with this particular instance, but someone down the road later. Other things going on, but there's no sense talking about it. I've got to get these engines built and out to the customers that are asking for them. All right, more next time.